Hello learners, this is Education Online program and our subject is chemistry and the topic is the period 3 elements. So here this is presented by teacher Lily and this course is for senior 3 and 4. So here we shall say that the period 3 elements, some of us may ask what is this? This is actually the row in the periodic table. Actually in chemistry we have what is known as the periodic table. So this is showing all the elements with their atomic mass and their mass numbers. So in period 3 it means here we have the periodic table is having or it is just like this. We have this is representing the periodic table and we name this as group 1, group 2, group 3, 4, 5, 6, 7 and 8. So we shall have this one as group 3, group 4, group 5, group 6, group 7 and group 8. So there are elements up here and we consider them as one of those elements in the periodic table. Here also we have a hydrogen atom, so or hydrogen element. So we shall have to know that in periodic table, this is how the periodic table may look like, and here we consider these as groups and these are known as the representative elements. So this below in between we call them as these are representative elements, and it is usually represented by A, and these in the middle are known as transitional metals, and you may find them named as B. So there are other lines in between, and this we call them as the lactanides and the actinides. So this is how we represent the periodic table. We have the representative elements. Here we name them as group 1A, group 2A up to 8. So this we call them, these columns we call them as the groups, and the row here we call them as the periods. That is why we say period 3 elements. It means here we are going to have period 1, period 2, and then we have period 3 because we have other element above here which is stand alone as a single element, but we consider its line as the period. So here we shall have period 2 and period 1, period 2 and period 3. So this is where we are going to study the elements. So this period 3 is having 8 elements. So we shall have period here period 3 we have 1, 2, 3, 4, 5, 6, 7 and 8. So there are 8 elements in period 3. So the modern periodic table is arranged in such a way, and it is representing the period is representing the row, and the group is represented by the columns, as I've already explained. So all elements within a period have the same number of the energy level. So we learned before that there are energy levels when you're distributing the electrons in each element. So here these periods they have the same number of the energy level. It means the level at which each electron is distributed. In this case we have 3 energy levels when we are dealing with period 3. So period 3 is having 8 elements, and it is having the same number of energy levels, and here this energy level amount to 3. So there are 3 energy levels in this period, which is period 3. So here we shall say that all the elements within a group have the same number of electrons. If you say a group, it has the same number of electrons. So at the end, if it is group 1, then the last electrons in each group, the last electrons for each group represent its group. For example, group 1 will have single electron at the end of the distribution of the electrons. So the third period contains 8 electrons, and these 8 electrons are sodium. We can have sodium as the first element in this period 3, and we have magnesium. So there is magnesium, and we have aluminium. We have silicon. We have also phosphorus. We have sulfur. We have chlorine, and we have argon. So these are the 8 elements that we have in period 3. We start with the sodium, we go to magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So these are the 8 elements that we have in this period. So learners, we have seen that I've shown you that these elements, they have the same levels of the energy. The energy levels, they are the same, which is 3, and it is represented by the number of the period. And here we have period 3. So aluminium is heavily used. What are these characteristics of these elements? We have aluminium. We have this one. Why? They have similar chemical properties. These elements also, they may have similar chemical properties. So aluminium is heavily used in making powder. So you can have aluminium. So we represent aluminium. Aluminium is heavily used in making of powder. Transmission cables, and major aircraft. So these, among others, are how we use aluminium. So it means these elements, they are very important in our daily life. For example, we have aluminium. It is used in this heavily used in making of powder, also transmission cables and others. So we can say that chlorine is used in water treatment. We can have chlorine. Chlorine is used in water treatment. Among others. So these are some of the example of their uses as we know that these elements, they are not only for fun, but they are very important in our daily lives. So magnesium is a major constituent of a chlorophyll, and sulfur and nitrogen have both wide industrial application as well as major nutritional values. So we say that these elements, like aluminium, we have sulfur, and nitrogen. Also, these two elements, they are considered as of nutritional values, for both plants and animals. For both plants and animals, it is very important in the nutrition. For example, for plants, it is for photosynthesis, and it is a way of plants when they get their food, and they manufacture their food through what is known as photosynthesis. So with this, we know that magnesium is a major constituent of a chlorophyll. So magnesium also is very important for plant, and it is a major constituent of chlorophyll. A major constituent of chlorophyll is magnesium. So with these few outlines, we have seen that aluminum is very important in our daily life. Also, chlorine is very important in our daily life, plus sulfur and nitrogen, and also we have magnesium. So most of these elements in periodic table, they are very important in our daily lives. So we can say that there is electronic configuration. Here we said, when we say electronic configuration of period 3. So here we are saying that the electronic configuration is the distribution of the electrons, distribution of the electrons of each element in energy levels. And here we can say that the electronic configuration of period 3 are represented by 3 energy levels for each element. So these 8 elements, they distribute their electrons into 3 energy levels. So how do we distribute that one? Previously we know how to distribute the energy level, but for the purpose of remembrance, we are going to have how do we distribute the energy, the electrons into their energy levels. So we shall have the first one, which is sodium, and by distributing the electrons, we need to know what is their atomic numbers. So here the number of the energy level is used to identify the period of the elements in the periodic table. So we shall have, this is represented by elements. We have symbols, we have atomic number, and then we have the electronic configuration. This is where the distribution of the electrons is. So the first element, which is sodium, its name is written as in words sodium, and its symbol is Na. The second element, which is magnesium, have a symbol Mg. Aluminium is Al. Aluminium is Al. Silicon is Si. Phosphorus and then we have sulfur. We have chlorine. Lastly, we have argon. So these 8 elements are going to we are going to show its electronic configuration, and we say that the first element here, which is sodium, and its symbol is Na. Also we have for phosphorus is P, for sulfur, chlorine is Cl, and then we have argon is Ar. So we have the atomic numbers for these elements. We have 11, 12, we have 13, 14 for silicon, 15, 16, 17, and we have 18. So these are representing the electrons, or it is shown as the atomic numbers. So when we distribute this, we shall have 2 at first level, and then the second level will have 8 electrons. Then from 11 we have 1. So here we shall have 2, 8, and then we have 2. So if you are seeing that we have 3 energy levels, so we have 1, 2, and 3. The same thing for magnesium. It will go like this for the whole elements in this period. So we have as aluminium is 283, silicon is 284, 285, 286, and we have 287, 28, and then we have 8. So all these elements are having 3 energy levels. So the electrons are distributed among 3 energy levels. So this makes them to have the same physical properties. So when we go to the physical properties, you realize that these elements are having the same physical properties or similarities in their physical properties. So we say that here we have seen that the 3 energy levels for the first element, which is sodium, and we said sodium here, these 8 elements, they are distributed, and we have to know which element is a metal, which element is a non-metal, and which one is not. So we have the first element, which is sodium. These are considered to be a metal. So we have to know that the 3 elements, which are the first 3 elements, they are considered to be metals, and the first 3 elements are sodium. So sodium, and then magnesium, aluminium, these are known as metals. So why do we consider them as metals? Because they are the elements that loses their single electrons. So up to here we have seen that there is 1, 2, and 3. So these 3 electrons are going to be lost. So it means when they lose electrons, we consider them as metals. So those elements, we have phosphorus, sulfur, and chlorine are considered to be non-metals. And for non-metals, they gain electrons. So we shall say that these are considered to be metals, because they lose their outmost electrons. They lose their outmost electrons. So we have silicon is an exception, and we shall have phosphorus. Let me explain about the other three elements. Phosphorus, sulfur, and then we have chlorine, then we have argon. So these three elements here, we consider them as non-metals. So when we consider them as non-metals, we mean that they have their electrons in the outmost cell, which is 5, 6, and 7. These electrons, we are going to top them up into 8 electrons, and we say they gain electrons to their outmost shells. So when they gain electrons to their outmost cells, then they will behave as a non-metals. So here they gain electrons to their outmost cells. So the last one here, we consider it as inert gas. So this inert gas, they neither gain nor lose electrons. Why do they not gain electrons or losing? Because their outmost electron is already filled with the 8 electrons. So they have a complete outmost cell. So complete outmost cells. So we have the one in the middle is a metal and a non-metal at the same time. So here we can say that silicon, it is behaving in two ways, either as a metal or it can be as a non-metal. So in this, we say that silicon has an exceptional property, and argon also is an inert gas, and here it has a complete outmost cell. So when we go ahead learning more about these elements, we shall see that those with the 8 electrons at their outmost cell, they don't react or they don't form compounds, but there are conditions that can make them to form compounds when we go further or advance in our chemistry learning or periodic table. So metals and non-metal is the two behaviors whereby silicon encounters. So sodium, magnesium, and aluminium, they are metals, and they lose electrons to form a compound. In this case, we shall say that they fill up their outmost electron by losing the single electron. So it is easier for the three elements to lose their electrons here. So it is easier for sodium to lose the single electron. It is easier for magnesium to lose the 2 electrons. It is easier for aluminium to lose the 3 electrons. So it is not easier for phosphorus to lose the 5 electrons, so they have to gain 3 electrons to top up this to be 8. Also the same thing for sulfur and chlorine with the 7 electrons in the outmost cell. So here we shall say that the 3 first electrons, they are considered to be metals because of those following reasons that I've already given. So also the non-metals are considered to behave like that because of their ability to gain electrons. So it is easier for them to gain the few electrons than to lose the more electrons. So for argon, it neither gains nor lose electrons. So with this, we have known that these elements in the periodic table are 8, and in the periodic table we have those elements in period 3 are the 8 elements, and they are very important in our daily life, as we have already mentioned in some of the examples that we have given them. And we know that we put them into period 3 because they can distribute their electrons into 3 energy levels. So with this, we have come to the end of this lesson, and thank you very much. I'm teacher Lily.